So in this next chapter, we're going to be dealing with trigonometric identities. So these are just equations that will help you change one trig function into another. And here is a list of those equations. So, and you will not have to memorize most of these, and actually I'll show you a way that you can get a lot of them. So there's what are called the reciprocal identities. Sine is the reciprocal of cosecant, and cosecant is the reciprocal of sine. We've already seen that with right triangles. Cosine is the reciprocal of secant, secant's the reciprocal of cosine, and then tangent and cotangent are reciprocals of each other. Then there's quotient identities. Tangent is sine divided by cosine, and cotangent is cosine divided by sine. And then there's what are called Pythagorean identities. Pythagorean theorem, a squared plus b squared is c squared. Well, it's true that for any angle, sine squared plus cosine squared of that angle is equal to 1. Tangent squared of an angle plus 1 is the secant squared of the angle. And cotangent squared of the angle plus 1 is cosecant squared. So you can accept all of these as givens. And an easy way to remember these is using something called the magic hexagon. So you just draw a hexagon, six-sided, and then draw all your diagonals. Put 1 in the middle. Put sine and cosine at the upper corners, tangent, cotangent, tangent at the middle corners, and secant, cosecant at the bottom corners. And if you do that, then the reciprocal identities, you just go straight through the middle. So sine is the reciprocal of cosecant. Here, sine is 1 over cosecant. And then the other way too, cosecant's 1 over sine. And then cosine and secant are reciprocals of each other. Tangent and cotangent are reciprocals of each other. To get the Pythagorean identities, look at any upside down triangle. The squares of the top two equal the square of the bottom vertex here. So sine squared plus cosine squared is 1 right here. For this triangle, 1 plus cotangent squared is cosecant squared right there. And then for this triangle, tan squared plus 1 is secant squared right there. And then the quotient identities you just get from going clockwise around the hexagon here. So tangent, and then the next two functions are sine and cosine. So tangent is sine divided by cosine. And you can keep going around. So for example, cosecant is secant divided by tangent. Sine is cosine divided by cotangent. So any function is the ratio of the next two going clockwise. Okay, so let's practice simplifying using some of these examples. So we want to simplify tangent x divided by secant x. So we'll go to our identities here. And tan x is sine divided by cosine, and then secant x is 1 divided by cosine. So we can rewrite this on the top. We'll have our main fraction on the top. We've got sine x divided by cosine x. On the bottom, secant is 1 divided by cosine x. And then if you want to divide two fractions, you just invert and multiply, right? So sine x over cosine x. And then times the reciprocal of the bottom, which would be cosine x on top and 1 on the bottom. And then these cosines will cancel. Cosine over cosine is 1, so we're just left with sine x on the top and 1 on the bottom, which is just sine of x. So that's simplified. So just change everything using the quotient and reciprocal identities. And then one of the things we'll do in this section is prove an identity. Here they start us out by just choosing the rule that's going to justify each step. So here they start with tangent times 1 plus cotan squared, and they change it to tangent cosecant squared. So they traded out this 1 plus cotan squared for a cosecant squared. So if we go back to our identities here, 1 plus cotan squared is cosecant squared. That's a Pythagorean identity. So this is Pythagorean. And then next, they traded out a tangent for sine divided by cosine. That's this identity, which is a quotient. So quotient. So you're just identifying which type of identity they used. Cosecant squared, they traded out here for 1 over sine squared. The other part stayed the same. So what they're using there is that cosecant x is 1 over sine x. Go to our identities. Cosecant's 1 over sine. That's a reciprocal identity. So this will be reciprocal. And then lastly, they ended up with 1 over cosine sine. So what they did was they just canceled the sine here with one of the sines down there and then multiplied straight across. So this leaves a 1. 1 times 1 is 1. Cosine times sine right there. So that's just algebra. So one set of problem, they'll just have you filling in the reasons here. What type of identity is it, or was it just algebra? Let's try another one like that. So here we start out with secant squared x minus 1 times cosecant squared. We want to show that it's equal to secant squared. So start out with your left-hand side right here. And then from there, we change it to tan squared cosecant squared. So they traded out secant squared minus 1 for a tangent squared. So let's go to our identities. So right here, tan squared plus 1 is secant squared. Okay, but we started with secant squared minus 1. Well, all you have to do is take this 1, bring it over on the right as a negative. You'll have secant squared minus 1 is tangent squared. So that is a Pythagorean identity. It's a rearrangement of this identity. So this step from here to here is Pythagorean. And then from here down to the next step, they changed a tan squared to a sine squared over cosine squared. So what they're using there is that tan x is sine x over cosine x. And then they square both sides. And that's a quotient identity because it's got a fraction on the right-hand side. That is this one right here, quotient. So that's a quotient identity. And then, let's see, from here to here, they kept the sine squared over cosine squared. They swapped out a cosecant squared for a 1 over sine squared. So there they're using cosecant x is 1 over sine x. And that's a reciprocal identity because it's got a reciprocal on the right-hand side. That is this one right here, which is reciprocal. And this list of identities here, that's at the very top of the unit. So, and I'll actually print that off on Monday. And then the last step here, they went from this expression to 1 over cosine squared. So what they did there was they just canceled the sine squareds. So that's just algebra. Because on the top, there's a 1 left. 1 times 1 is 1. Cosine squared times 1 is cosine squared. And then 1 over cosine squared is secant squared. So there they're using, let's see, they're using secant x is the same as 1 over cosine. That is this one right here. And they squared both sides of it. So that's a reciprocal identity, just like this one was. And that problem's done. Again, we're just filling in which identity did they use, or was it algebra? And then the next step is when they don't give you the steps. So now you got to come up with the steps and tell what reason it is. So we want to show tan squared x times cosecant squared x minus 1 will just give you 1. So let's start on the left-hand side here. Tan squared x. And then this cosecant squared x minus 1, I think we can use a Pythagorean identity on that. So let's go to our identities. Cosecant squared is cotan squared plus 1. Take this 1 and bring it over as a negative. So cosecant squared minus 1 is cotangent squared. So cosecant squared minus 1 right there is cotangent squared. So equals, and that was a Pythagorean identity. And then next up, let's see here. Tan x is sine over cosine. So tangent squared x is going to be sine x over cosine x squared. And then cotangent x squared. Cotangent is cosine x over sine x. And then that gets squared. So both of those are the quotient identities. Those are right here. Tangent sine over cosine. Cotangent is cosine over sine. And so this was quotient identities. And then to square a fraction, you just square the top and the bottom. So we square the sine. So that's sine squared x. Oh, by the way, if you hadn't seen this notation before, that exponent in the middle, sine squared x, that means the same thing as sine of x, whole thing squared. It's just a shorthand so we don't have to write the parentheses. And then on the bottom, we square the cosine, so cosine squared x. And then here, square the cosine on top, cosine squared x, over square the sine on the bottom, sine squared x. And that is just algebra. And then note, look here, sine squareds cancel and cosine squareds cancel. So that just leaves 1 every place. So that's just 1 divided by 1, which is 1. And that's also algebra. So look at your expression and, see what identities you can trade out for. Just try some things. A little bit of it's trial and error. Notice we changed the sines and cosines. That's kind of one strategy that you can use. Let's look at another one here. So they want us to show secant squared minus 1 times cosine squared is sine squared. Okay, so let's see. The secant squared minus 1, I think we can trade that out. I believe that is tangent squared. So let's go back to our identities. So let's see right here. Tan squared plus 1 is secant squared. Take the 1, bring it over as a negative. Tan squared, secant squared minus 1. So secant squared minus 1 there is tan squared x. And then times cosine squared x. So that left-hand side equals this. And then that was Pythagorean. And then let's see, let's trade out that tan squared for sine x over cosine x squared, which will be sine squared over cosine squared. If you'll let me do 2 algebra steps in one. Or actually, that would be quotient identity plus algebra. And then times cosine squared x. So that was the quotient identity. And I did algebra plus algebra. Probably should have done that in 2 separate steps. And then let's see, cosine squareds cancel. Just leaves 1 and 1. So we've got sine squared x. And that's what we wanted here. So we started with the left-hand side and did, oh, this was algebra. And then worked just on that left-hand side until we got to the right-hand side. That's a primary technique of proven identities. Okay, so you should be able to finish up section 6.1 and Aleks.